Hello students. Today we are going to be going over 14.1 rates and factors. So our objective is I can apply the rules of exponents. We need to know some vocabulary. There is percent change, which is the extent to which something gains or loses value. Decay or decreasing percent, there's a decrease in value. In decay problems, the original value is more than the final amount. A discount is an example of decay. The decay factor is the final amount written as a decimal. Growth or increasing percent, there is an increase in value. In growth problems, the original value is less than the final amount. Taxes and tips are examples of growth. Growth factor is the final amount written as a decimal. So remember how we convert decimals and percents. If we're going to convert a percent to a decimal, we divide the percent by 100, or we just move the decimal 2 places to the left. If we convert a decimal to a percent, you move the multiply the decimal by 100, which is basically moving the decimal right 2 places. So here, we're going to go ahead and say, okay, let's 0.753, convert it to a percent. So the way you would do that is we would just put 75.3%, okay? 52%, convert that to a decimal, 0.52. And I'm super picky about writing the 0 in the front, okay? So then 0.023 converted to a percent, we say that is going to be 2.3%. Don't think that it's 23%. It will be 2.3%. This one right here, it's 125%. We're going to convert that to decimal form. We move the decimal 2 places over. It's here at the end. So it's going to be 1.25. And there's an example for you to know how to convert decimal and percents. Okay. Now we're going to talk about growth and decay. In a growth problem, the 2 parts add up to more than 100%. The final amount is more than the original amount. Like if you have a bill and you went to a restaurant, you're going to leave a 25% tip, then there's an increase and you would have a total of 125% of the original bill. So that's an example of the growth. The amount in the end is more than the original. It's percent increase. So for this, the percent increase is 25%, and the growth factor, which I don't know if I can move myself. I didn't know if I could do that. Now I just learned something. That's cool. So anyway, the growth factor over here is 1.25, okay? Now, with the decay problem, the 2 parts add up to 100%, or the original amount. So if you have a 20% decrease, 20% off, like if you go to the store and they have a 20% off sale, then they take 20% off, and then 80% will be the remaining amount, or it would be the cost of the product that you happen to be buying. So again, this is an example of decay. The amount left is less than the original. It's a percent decrease. So in this case, it's a 20% decrease. The decay factor is 0.80. If it was like a 30% here, then this would be 0.7. So that's how you figure the decay factor. So you can take 100% minus whatever this is and then convert it to a decimal. This one, percent increased, add 100 to whatever it is, and then change it to a decimal form. And that's how you do that, those types of problems. Okay? All right. We'll go on to the next page in the next page. Okay? So we'll see you in the next video.